Okay, so now we want to be able to understand transformations of these common functions, how to apply transformations, how to recognize transformations. Yeah, that's about it, I think. Alright, so f of x equals the quantity square root of x plus 2. I want you to pause the video and write down how you think this function changed from its common function, which a hint is the common function is the square root. So pause the video, write down your description of the change. My hint for this is just to show you on top of each other that this is the common one. Pay attention, pay very close attention to those points that I used to identify the common one. That's going to help you out on all of these descriptions. Okay, so pause the video. Alright, same thing. I want you to think about how did this function f of x equals the square root of x and then minus 2, how did that change from the common function? Pause the video, write down your description. Here, f of x equals the square root of the quantity 2x. What is the change that happened from the common function? This one is crucially important, and this and the next one as well, to identify. Look at those points that I identified before from the common function. So think about how did those points change. So it's crucial that you identify or look at those points to really understand this change. Pause the video, write down your description. Same thing here. Focus on those points. Describe the change from the common function. Pause the video, write down your description. Okay, here, if you understood correctly the change in this function, then that change is still occurring for f of x equals the square root of negative 2x, but now there is one other element added. So write down the description here. Pause the video. Do that. And then last but certainly not least, write down the description of this one as well. F of x equals negative 2 times the square root of x. And again, a lot of this change will still be the same as 2 times the square root of x. How is the negative really affecting the graph here? But write down the full description. Pause the video. Do that. Okay, last example. So now, look at the descriptions of the changes that you wrote before. And now try to figure out how is this function going to change. Also, I'll give you a hint. So this f of negative 2x, that is the same type of transformation as what we had here. So if you understood this transformation, that is how the negative 2 is affecting this f of x function. The minus 3 is the same as the transformation here. It was minus 2, but still same idea. So if you understood that transformation, that's what you are going to apply in this case. So we are trying to draw this new function h of x. My other hint for this, because you are going to do this on your own, is really you only need to look at or transform these points. If you transform each of those points correctly and then just connect the dots with straight lines, you will come up with the correct solution. So I want you to pause the video and try to perform this transformation. Unpause when you're ready to check your work. Okay, so this should be your result, your h of x. Now I color-coded each point so you can see. So this point here on the original function f of x, the point negative 4, negative 2, became the point positive 2, negative 5. The point negative 2, 1 became the point 1, negative 2. The point 2, negative 1 became the point negative 1, negative 4. And the point 6, positive 3 became the point negative 3, 0. So if you did not get the correct solution, look at those points and see if you can figure out what you should have done differently. Because again, the point of this is you are supposed to discover what to do. I'm not just going to tell you what to do. You need to discover it. Also, this isn't new. You have done this before in the past. Okay, transformations of functions include resizing, stretching or shrinking, translating, which is shifting, and reflecting, which is flipping the function.